Hey, welcome to D-Lab everyone. Have you ever found yourself in the situation where you want to build, let's say, a little tube amplifier? You get down in the basement, you find this transformer hanging out, but you have no idea what the outputs are of this unknown transformer. There's no part numbers on it. How do you determine if this transformer will fit your application? Well, in this video, I'm going to show you a method where you can test this transformer and hopefully it'll fit your needs. Alright, here we go. The unknown transformer testing method. The first step is to identify these leads, and then we're going to tag them. So most US manufacturers of transformers followed a standard color code format. So primary was normally black and white. Then they had a pair of yellow leads. This was normally 5 volt AC. And then you had green leads, which were normally 6.3 volt AC for the filaments of your tubes. And then the high voltage is normally red with a red-yellow center tap. And that's what this transformer appears to have. So what I'm going to do is pair these up, and then I will tag them with some masking tape. Okay, so for example, I'm guessing this is the primary. So we will tag that as primary. Okay. And then obviously the yellow leads would be my 5 volts that would go to a rectifier tube filament. And then we have our high voltage. That's these 3 leads. Okay? So I'm going to get all these tagged up, and then we'll grab a meter and buzz out the leads and see if we have continuity on those windings. So the 6 volt one is kind of a bit of a mystery because it's normally 2 greens, but I'm guessing in this case they used a green brown. High voltage is pretty obvious, 5 volts pretty obvious, and so is our primary. Alright, next step. After pairing up and tagging our leads, we're going to test them with an ohm meter. So on the filament windings, you're going to see a very low resistance as well as the primary, but the high voltage winding, since there's a lot more copper there, it's going to be maybe several hundred ohms. So we are going to verify the resistance, and then we'll test each winding to case of the transformer to verify there's no shorts. So let's start with our primary. My meter is set at ohms, 0 to 600 ohm scale. So there is my primary, about 7.7 ohms. Here is the 5 volt winding. See there, very low. My 6 volt winding, same thing, low resistance, and now the high voltage. So the high voltage, the winding is between the 2 reds. Okay, so you see about 177 ohms. If I go from one of the reds to the center tap, this can be half of that value. Okay. Alright, so now that we verified that these windings are okay and tagged appropriately, the next thing we want to do is verify that none of them are shorted to the case of the power transformer. If they are, your testing is over. So I have my meter set up, negative is to the case, so if I go to the other side, you should see continuity. Now we're going to check each pair of wires. So I've got the 5 volt windings here. We only have to check one lead because it is a winding and we already verified those are good. So that's open. Here is my 6 volt winding. Open. My primary. Same deal. And the high voltage windings. So none of these leads are shorted to the case of the power transformer. So now we can actually apply AC to the primary and measure the outputs. Okay, at this point we're going to be applying 120 volt AC to the primary of the power transformer. So I have these little clip leads going to my AC plug. You want to be very careful when you're doing this testing that none of these exposed leads touch each other or you. Okay? So we're going to check one set of windings at the time. We'll start with the filament lines and we'll work our way to the high voltage windings. Alright, we're going to start out with the 5-volt AC winding. Now keep in mind, this transformer is not loaded, so you're going to see higher than normal voltages. When these are in your amplifier and they see the loads of filaments and the high voltage system, that voltage will go down. But this is just a way to get you in the ballpark and make sure that we're getting the voltages that we're expecting to see. Now, a Variac is highly recommended, but I know most of you do not have that. So we're going to do this by simply applying the AC direct with this power cord, watch our meter, unplug, and go to the next set of windings. Okay, here we go. I have the primary of the power transformer going to these little alligator clip leads, which goes to the AC plug. We're going to be looking at the 5-volt winding first. The other windings are isolated, not touching anything. So here I'm going to apply AC. You see we got about 5.8 volts on those windings. Now we're going to move over to the 6-volt windings and repeat that same test. So here's the 6-volt winding. See, we have 7.46. As I stated, all these voltages are going to be higher than expected until they're loaded. Now we're going to move on to the high voltage windings, but I have some information that I need to share with you first. Now here we go. We're going to check the high voltage winding of this power transformer. Now remember, this is an unknown transformer. We do not know what that high voltage is. So I have a couple words of caution. Number one, when you get ready to measure this, do not connect from red to red. We do not want to throw the entire potential of that transformer into the meter. We're going to go from red to red yellow. So let's say we saw 200 volts AC. We would know that this is a 400 volt center tap high voltage winding. The other issue that you'll run into measuring this high voltage is your meter itself. A lot of the lower end multimeters have a limit of 600 volts AC input. This Hioki can handle 1,000. Okay, so let's say this was a 1,000 volt center tap transformer and you hook the two reds to your meter that could only handle 600. You're going to damage it. Okay, so that's why I say you should always go from red to the center tap, and then whatever that is, you're just going to double it. So we are connected, everything else is isolated. I'm on the 1,000 volt AC scale. Let's see what we get. 330 volts. So this is a 660 volt center tap transformer. Of course, once it's loaded, that will go down. Alright, there you have it. Now you can go down the basement, get that box of miscellaneous transformers, buzz them out, identify them, and use them for projects. Save yourself the big money of the cost of new transformers. More tech tips coming your way from D-Lab Electronics. Hope you enjoyed it.